continue from the end of previous video. So here we just want to show you, remember before we always talk about after the simulation, we will have the empirical distribution and we compared observed data to calculate the p-value. And that's very important. We need to choose the large number of the simulation. The reason here, we just want to prove to you. Earlier we used the sample size is 100, 1,000, then this one is 10,000. So we just repeat, have two groups. Each group we do 200 times to simulate the whole thing. So that's why you can see when we have the 100 earlier, the two groups, they are not really covered very well with each other. So that means the result, the simulation result, quite different when you have a smaller simulation, a smaller number of the simulation. So they will have more variety in there. So then 1,000 is better. So then you can see here the 10,000, the two groups basically overlap with each other. So that's the reason here we just want to prove to you. Why earlier we always say we need to have a number of the big number of the simulation. So continue. We already demonstrated the discussion question for the super soda. So continue with our demo. We want to discuss two questions. The first one I just showed you from the previous video. We changed the number of the simulation. Okay, so then when we do the simulation, it's better have a big number of the simulation. Then our result will be more close to the null distribution. So then the next question is, we want to see how reliable our hypothesis testing is. So then here we want to show you how that will be affected. Because here, before we talk about, we have the 200 data, 200 in the sample size. Then we have the 91 people prefer super soda. But you can know here, if you change the 200, it's just our sample size, right? So you do one time survey about that. So then now, for example, if you want to do again another survey, another test, so then you will have another 200 people. Will they still have the 91 preferred super soda? Or on the other hand, do they have much less people or much more people prefer the super soda? So here we want to show you one thing is how reliable our hypothesis testing is. So how to prove to you, to show you how our hypothesis testing is reliable or not. So this one here, we will just suppose we know the true proportion from the population. Of course, we don't know how many portion in the population. That's why we want to do the sample testing. We want to do the hypothesis test, right? But now here, since we want to see how reliable our hypothesis testing is, so then we just assume, hey, we do know the true population. So here we just say, because before we say the null hypothesis is, we don't have any difference between people prefer super soda or rival, right? So our null hypothesis is say, people like super soda as a rival. So that's why we just assume here, our true population is 0.5, right? So the true population is 0.5. That means people choose the super soda or the rival will be the same. Okay, so that's why here, now let's see how to prove. So that's why, let's do another sample data. Okay, so the same thing here, let's choose the sample size, still 200. Okay, so according to, remember we have the sample proportion function. You pass in the sample size, you pass in the distribution. So then here we can get our result. Okay, so here we just want to know the result, because here the result, they just have the proportion. So let's multiply the sample size. So here, then you can see, right, if you just assume half and 50-50, so we just do one sample test, then you got 95 like super soda, 105 like the rival. Of course, you can run many times. Okay, so that's each times. Okay, so they give you the result. Okay, so now let's do some experiment running. Okay, so we want to do the testing. Yeah, many times, right? So that's why we have many times testing. So that's why we can see our conclusion is correct or wrong. Okay, so this function we call run experiments. Okay, so of course, the first thing, tell me how many times simulation you want to do. We just do 10,000 as earlier. So the sample size here is 200. So that's why this function we can change later. So that's why we have 3 input. The number of simulation, the sample size, 200 for now. So then the true proportion, later you want to change your proportion, you can change. So here the true proportion just means how many, what is percentage we prefer the super soda. Okay, so that's collect our data. Okay, so since we have the portion for the super soda, so that's why we're making an array. Okay, so this array is people like super soda and people like the rival, the ratio. Okay, so then the same thing like earlier on our test sample result, we just multiply that. So as earlier we do here, after you run each time, so actually the first number is our new observed data. Okay, so that's why we got that we use item 0. Okay, so why we need that? Because here, just like said, we assume, okay, since that's our null distribution hypothesis, so we do 50-50. So we see what happens if we really do the hypothesis testing. Okay, so the same thing earlier, our count, you just run the test. We already defined earlier. Then you have your number of simulation, your sample size. So then the p-value, right? We just calculate our p-value, see the result, how it look like. So then we see we will either reject or do not reject the null hypothesis. So how to calculate will be the same. But remember, before when we do that, we compare our observation data is 91. But here, since we do another assumption, so we will create our new observed data. So that's why here you will have using this one. So we're using this one to observe from the sample to do the comparison to find the p-value. Of course, they still need to divide by the count. That's the sample size. Okay, so then here we just run. So here we just assume we do 10,000 tests. The sample is still 200. So then you see no difference. So we do the 50%. Okay, so then you see you run. Okay, so every time you run, you see, oh, that's become a big number. Okay, so this big number, actually, we do not reject the null hypothesis, right? But see, you can run many times. Yeah, actually, it's good. The value is very good, very big. So mostly, yeah, we do not reject. Okay, because on the population is 50-50. So then our p-value result actually match our result. But one thing, the same thing, we always say, you run 1 time, 2 times, 3 times, it's just not enough, right? So how about we just do again? Let's see how confident from our hypothesis testing. So that's why the same thing, we're using the 50%. Okay, sample size is 200 for now. Let's run 100 times for this simulation. Then result, we will get our p-value, right? So we have 100 p-value. Then we see this p-value, let's make the histogram. So we want to see the result. We see our p-value, how much we will reject no hypothesis, how many we will do not reject. So that's why here we run. Okay. So here, since we run, yeah, okay, good. So actually each simulation we run 1,000 times. So that's why we got our result. So that's our p-value distribution, right? So actually our population, we assume that's 50-50. So then we just say 5% we will reject. So then you can see here, we just see here is 0 to 1.2. So half is 0.1. So then 0.5. Okay, so then you can see actually the 0.5, actually almost like this one, 0.2, it totally have nothing. So this one maybe we just say is 0.2 to 0.5. So then the interval only 0.03. So times 125. So on the other hand, actually only less than 4%, the p-value will be very small. That we will reject our null hypothesis, right? But that's false. Yeah, because the null hypothesis is really true because we use the population is 50%. So on the other hand, when we do this way, we show you our hypothesis actually is very high accuracy. Or we have less than 4%, it will get it wrong. Pause the video and think about that and discuss with your classmate. If you have any question, of course, post in the discussion. Okay, so that's why we back to see here how reliable our hypothesis testing. So that's why we show you how we can simulate the new observed data. Then the same thing, we run so many times for our whole simulation. Then we compare the p-value. Yeah, very good. Actually, we only have 4%, less than 4% chance our hypothesis and conclusion will be wrong. Okay, so that's how reliable our hypothesis testing is. And also the last one I also want to show you. But before I show you this one, then I want to give you some conclusion. That's the purpose for this lecture 4. We have so many different hypothesis testing example to show you. So then you need to remember the outcome for the hypothesis testing can be affected by a few things. The first thing, the hypothesis you are investigate. So then, right, how you define your null distribution, that is very important because how you define your null distribution, they will also mean how you will run your simulation. So that will be very careful how we define. Then after we define the null hypothesis and alternative hypothesis, we will decide our test statistic, right? Okay, so that's why here, how to measure the difference for the sample. The test statistic is important. So then the empirical distribution is how we define to find the observed data difference and find the p-value. So of course, the empirical distribution, how to get that is important. And how really affect empirical distribution is your number of time to do the simulation. Okay, so then of course, when you do your sample data, your observed data is the sample you collect, right? We really need to make sure our sample is really similar to our population. So that's why we call the random sample. Okay, so then if the alternative hypothesis is true, okay, so then how extreme the difference is. So this one actually, that's why I want to show you. After you understand those concerns, so when we have our hypothesis, when we have our population, so earlier we just say is 50-50. Okay, so people prefer the super soda and the rival is the same. But sometimes maybe they kind of similar, but they still have some different. If I have my true proportion, actually only 45% people prefer the super soda. When the chance, you see here, we do say the alternative will have less people like the super soda, right? But sometimes this proportion is really small. So then you see here, we're still using the sample size 200. Then if we run this again on the simulation again, so I just want to show you, when you have your true proportion, your difference from your alternative hypothesis is really small, then sometimes if your sample size is not big enough, then we possibly have a lot of error will happen. Because here you see they do have less people like super soda, right? So then we will see here is 0.1, 0.5 we will reject. But actually reject here is correct, right? Because they are really small. So that's why you see here actually it's quite a big chance than before we will reject and we will actually accept the we will do not reject the null hypothesis. But again, if we make the sample size a little larger, 500, right? Okay, so then we see the error will become less or not. So did you see here? Because one thing is, you see, almost all of that is within 0.05. So earlier here we have more data, but now they have much less data. So that's earlier we say this one. When you have your alternative hypothesis, it's true and also very close. Very close. The difference is very close. But then the sample size for your observation, the larger will help us to get more accurate conclusion. Okay, so if you have any question, discuss with your classmates. So of course, I will spend a little more time in the next lecture when we do the midterm review to help you understand better about the hypothesis testing. I will stop here for our lecture 21.